Hello. Today we are looking at a problem where you initially invest $500 in a savings account that pays a yearly interest rate of 4%. We are asked as our first question to write a formula for the value of the account in years since your investment. Because this problem is based on percent, we are going to be writing an exponential formula because exponential formulas capture things that change by a percentage. So as our base formula, we have n equals p times a to the t power. And we have previously defined that n is the amount. So here n would be the amount of our investment. P is that beginning amount, and so when we look into our problem, our initial investment was $500, and so we'll put that into our formula for P. Next, we need to calculate A, and we've talked about A equals the growth or decay factor. So I started to write A there, but I really want to figure out a value for A. So we know that because this 4% would indicate growth, that we should take 1 for 100% and add the 4% as a decimal, so 0.04. So that'll give us an A value of 1.04. We also talked about previously that anything bigger than 1 would indicate growth, and so we definitely should have a value that grows here in our equation. So here where I was about to write A, we'll replace that with 1.04, the actual growth factor for this problem. And then we have t, the time, as our other variable. So question 2, ask us to find the monthly growth factor. To do that, we're going to use this chart just to keep track of things. So initially we had found A to be 1.04, and that was the growth factor when time was measured in years. Now we want a growth factor when time is measured in months. And so we want to look for the relationship here from year to month, and we see that a month is 1/12 of a year. So that means that we are adjusting the time in our formula to be 1/12 as long. So what I'm going to do on my calculator is take 1.04 and raise it to the 1/12 power, because our time, which is our exponent, is 1/12 as long. So I'm going to go to my calculator and put that value in my calculator, and so I write that down here. What is the monthly growth factor? Well, we get that by taking 1.04 to the 1/12 power, and my calculator gives me 1.003273, and it continues. Then it asks me for a different question, and that is, what is the monthly interest rate? So to figure this out, I have to go back and look how I took this percent, the yearly interest rate, and made it into the growth factor. The way I did that was by adding 1. So if I want to undo that, I want to take this growth factor and subtract 1. So when I do that, I have 0.003273. Now I have to take that decimal, because you see right here we had a decimal, and convert it back to a percent. So I do that by multiplying by 100, and that would give me the decimal 0.327. And here is where I round to 3 decimal places like it asked me, and that value is a percent. All right, so we're going to do another example here, sort of the same thing but slightly different. This time it asks us to figure out the decade growth factor. So we knew that 1.04 was the growth factor for a year. We figured out for a month, so now we want to figure out for a decade. Always a good idea to go back to start. So from year to decade, what is the relationship? Well, it would be 10 times as much, because a decade is 10 years. So that means I'm going to take 1.04 to the 10th power, because the time is now 10 times as long. So I do that on my calculator, and that is going to give me the factor for a decade. So typing that into my calculator gave me 1.48024, etc. Okay. Then it asked me, what is the interest rate? So for the interest rate, I have to go back here, exactly how I got the growth factor in the first place. I would have to subtract the 1, and so that gives me the 0.48024. And then that is a percent as a decimal, so I have to multiply by 100 to get that as a percent. And so I get 48.024% as how much interest it would earn in a decade. So some really important things in this problem. The first thing is the way that we make a growth factor is taking 1 for the original item and adding the percent of growth. That's how we got the 1.04 for a year. When we want to adjust that for a different time frame, we have to look at the relationship. And so a month was 1/12 as long, so we used an exponent of 1/12. Whereas a decade was 10 times as long, so we used an exponent of 10. Also important, when we're asked for a percent, we then have to subtract out that 1 that we originally added in, and then we have to multiply by 100 to take that decimal back to a percent.